Hello, this is Alex Eames from Raspberry.tv. This is the BitScope Micro, which is a very small USB oscilloscope and logic analyzer and function generator for the Raspberry Pi and pretty much any other computer. There's drivers and software that help it to run on Linux, on Mac and on Windows, and also on ARM hardfloat Raspbian for the Raspberry Pi, which is what I'm running it on here. It's actually quite a nice piece of kit from a company called BitScope Designs in Australia. So here we've got a Raspberry Arduino board, which is basically a breakout board for an Atmega 328P chip, which can be connected to the Raspberry Pi. There's a Raspberry Pi in the back of this HDMI Pi, so I've used a ribbon cable to connect it so that you can still see it. It's programmed by the Raspberry Pi using the Arduino IDE, which I will bring up on the screen so that you can see it. It's programmed so that this LED is flashing with 50 millisecond intervals, and basically the BitScope is connected to that so that it measures the pulses. So that's what you can see on the screen. It's your 50 millisecond pulses, and it's a fairly square wave. This is really a demo just to show that the scope can run, and also it can cope with, the Pi can cope with running the Arduino IDE. So what I've done is I've doubled the time. So these pulses, the width of these pulses should double in a moment, but we just have to compile and upload the sketch. So that's Control Shift and U. It takes about 20 seconds to do that, but once it's done we should see the scope will pause for a little bit and then it should display. It's uploading the sketch now. It's kind of in the pause. And then the new pulses should be twice as wide as they were before, which they are. So let's get rid of the Arduino IDE and give you a good look at that. Now for this sort of thing, running the BitScope on the Pi is great. For things like fast changing signals, like the sweep sketch, where you've got a PWM signal that ramps up and down, it's a bit less good than, say, my Mac at freezing the action. Although it does capture it, it's not quite as good, but then it's not really surprising because that's quite a lot going on in that. So this is a measurement of the output from the Arduino sweep sketch. So you can see the sweep sketch pushes a PWM signal to Arduino pin 9, and I've got a probe going to the analog port of the BitScope, and the other probe is linking to ground. Basically is a fairly rapidly changing PWM signal, and as you can see it works really well. This is on my MacBook Pro. It doesn't work quite as well on the Pi because for some reason it doesn't lock on to the rapidly changing signal. I expect it's just a little bit too much processing for the Pi to cope with. And here's what happens when you run that same sketch on the Raspberry Pi. As you can see, it doesn't refresh as often, and it has a little bit of trouble locking into the x-axis. It's fine for fairly stable signals, but for quickly changing signals it doesn't seem to be as good. So let's have a look at signal generation mode. I've connected up pin L4 to one of the analog input channels. So what we have here is a tone output of a sine wave, and you can mess with that. You can mess with the symmetry, so you can change what it looks like. 50% is nice. You can change the frequency. You can change the amplitude and the offset as well. I'm not going to do that. So the other thing you can do is you can change it to a step wave, which gives you a square wave. And likewise you can mess with the symmetry and other things as well, like before, and the frequency obviously. And lastly, you've got a ramp function that gives you the capability of doing a sawtooth wave. So let's skew it to one side a bit. Okay, so you can also put that in mixed view, which enables you to see what function you've generated, and also you can see the logic inputs from all the input channels at the same time. So you can use this particular mixed view no matter what you're using the scope for. You can have it connected to something else as well. It doesn't have to be a function generated by the other parts of the scope. You've also got a dual input here, which I haven't got the other channel connected to anything, so you won't see, so that's why it's flatlining in the middle there. And the last one is logic. This gives you the inputs for all the channels, and you can hook it up to SPI or something, and you can actually use that to debug the trace from your SPI program if something's not working right, or you can check that things are working right, and I'm going to do another video on that quite soon because it's really interesting. This was Alex Eames for Raspberry.tv. Thank you for watching.